In the following video, I'm trying to explain an environmental policy instrument which has been discussed a lot lately and which has found a lot of supporters, especially environmental economists, and to further the understanding of why people support this kind of system, what the rationale is behind it, and what the benefits are of the use of an emission trading system, which is also called cap and trade system. So the first argument most economists bring forward to support cap and trade system is that it is market-based policy instrument which achieves an efficient outcome and is the least costly way and to achieve a certain amount of emission reduction, which means that it's cost effective. Another notion of cost effectiveness would be that you have a certain budget and want to achieve the biggest bang for the buck, but in this case it is actually just the least costly way to achieve a certain amount of emission reductions. The second argument economists would bring forward to argue for a cap and trade system or any market-based instrument is that there are behavioral incentives for the actors within the system to even exceed the prescribed emission levels or the amount of permits which they have, because they can sell those excess permits on the market. So to really understand what the cap and trade system is about, economists normally use this very simple model in which there are two firms, so a firm A which is some sort of industrial plant which emits a pollutant X, and then we have a firm B which faces a different kind of costs to reduce their emission of the set pollutant, but it nevertheless emits the same kind of pollutant. So they both emit a pollutant X. And what is important is that they add to a common pool of pollution. So there is, for example, if we talk about CO2, there's the atmosphere, and they both add to this common pool of pollution. And what is also important, that the pollutant distributes well in the system, in the common pool of pollution, so there are no locational effects on where the plant actually is situated. So one of the perfect examples of such a pollutant is actually CO2 or greenhouse gases. So to conceptualize what is meant with marginal abatement costs, or costs of reducing emissions, we or economists normally assume this kind of graph. I'm trying to show you here on the side, and we have the emissions of firm A, emissions firm A, and then the marginal abatement costs. Abatement costs, abatement costs in dollar terms. It's mostly expressed. So we have this kind of system. Let me just clean up this graph a little bit. So here, yeah, and without any kind of regulation, the firm A is gonna pollute, because pollution is a side product of its original output. So it produces the emission of the pollutant on the side, like it's an externality it creates with the normal production, and so it would produce a certain amount of emissions if there aren't any regulations, which is E0, which is exactly the amount of the pollutant produced by its current economic activity. But the firm can scale down its emissions by, first of all, either reducing its output or installing some kind of scrubber, which is going to be a costly endeavor, and so it's going to face, for each unit of emissions reduced, a certain amount of costs, which can be seen here on the graph. So the green line are the marginal abatement costs of firm A to reduce its emissions. M, A, C, A. And as we move along this graph and reduce the emissions further and further, we have increasingly higher marginal costs. So the first few emission reductions are relatively low, like it just is a marginal amount of this kind of costs here. But as we move further along the line, we face higher and higher marginal abatement costs, which means the total abatement costs are even exponentially high. Total abatement costs.